Okay, this is the notes that I've been telling you about that are so important for transformations. What I'm going to do is I'm going to give you kind of a basic introduction to all of the different transformations that we'll be doing this year. We'll talk about translations, then this video will stop and I'll do another video for reflections, then another video for rotations, and then finally one for dilations. That'll keep the video size small, so that way when you're doing this on your computer it doesn't take all day to load. So here we're going to do. First thing you're going to do with your notes, if you've got them from class, is you should have drawn the initial of your first name in quadrant 1. So remember, quadrant 1 is the one in the upper right-hand side. And we're just going to write that first initial of your name. So for me, my first initial is a B. So I'm just going to write it in there in each of these first quadrants. And I'm not going to be real specific about where it hits in the points. This is just kind of a general reference. Okay? All right. So, a translation. Okay, another word for translation is a slide. Okay? In other words, I'm simply going to slide my B around the coordinate plane, but the orientation is going to stay the same. In other words, it's not going to rotate any. Okay? So, for example, if I wanted to translate this left and then down, okay, so I would say I'm going to go left so many units and then down so many units. Maybe my new B ends up here. Okay? Or if I wanted to go up and to the right, we could do that too. But again, notice the orientation's the same. It still looks the same. A B is a B. All right? Well, let's look at reflection. Okay? Sometimes these are known as a flip. What we're going to do is we're going to reflect or create a mirror image of the shape. We need two things. We need our initial shape, obviously, so in this case, my B. And then for the reflection, we also need a mirror. In this case, I'm going to make the y-axis my mirror line. Okay? So in other words, if B were to look into the mirror, what would it see on the other side? Well, if my B looked into the mirror, it would see a B on the other side, maybe looking like this. Notice this is a mirror image of the other. Okay? Now, we can also use, instead of the y-axis, we could also use the x-axis as our mirror line. So again, if B looked into a mirror down here, then it would look something like that. Again, a mirror image, reflection. Right? Talk about rotations, okay, also known as turns. You need a few things for rotations. You obviously need your starting shape, so this is our B, our pre-image. And we also need a point at which everything's going to turn about. We always assume that the origin is our point of rotation, unless we're told otherwise. We also assume, I'm going to write this in, counterclockwise. Okay. Again, more than likely, Rene Descartes was a left-handed individual, and going counterclockwise makes more sense to left-handed people. So we're always going to assume our rotations are counterclockwise unless we're told otherwise. So if I were to rotate this around this point, let's say we're going to go 90 degrees. So I'm going to go counterclockwise in a 90-degree path. The way it's going to look is like that. Okay, imagine this entire page being held down at one point. If I were to rotate it around, that's where my B would end up. Okay? If I rotated a full 180 degrees, okay, the B would look something like this, if I can get my pen to draw. There we go. So that would be a 180-degree rotation. Okay? Or if I wanted to go 90 degrees clockwise, then my B would look something like this. Okay? Again, all of these rotations are occurring around this central point. All right? Last but not least, let's talk about dilations. Dilations are kind of like what your eyes do. Your eyes can either reduce in size, okay, your pupil, or enlarge. So what we're going to do here is reduce the size of our B, so I'm going to make it smaller. Now again, dilations also need a point that you're either reducing towards or enlarging from, and again, we always assume that that's the origin unless we're told otherwise. Notice my B appears to kind of move closer to the origin, but it's also smaller. If I wanted to enlarge it, for example, if I wanted to draw a B, notice it's going to appear farther away from the origin. All right? So these are each of our transformations. The first three, okay, are what we know as rigid transformations. Okay? We call them rigid because, just like that name would suggest, rigid, something that doesn't move. Notice in all of these, my B still looks like a B. It's still the same size, still the same shape. In other words, they're congruent. Okay? Rigid transformations are congruent transformations. But notice dilations, they're a little bit different. They're not always going to end up congruent. But notice this V and this V are similar. Okay? So whenever I translate, whenever I reflect, whenever I rotate, I'm always going to have the same shape. But when I start dilating, then things can become similar, not necessarily have to be congruent. All right? Well, let's take a look at translations in a little more detail. Okay? Let's take a look at our first example, and I'm going to get that out of our way. So let's draw our triangle. We've got triangle MNP, and it's located at the following points. So let's go ahead and graph them real quick. So M is at 4, negative 2. So I'm going to go right 4, down 2. Maybe. There we go. So we will go right 4 and then down 2. Now you always want to label your points. So this was point M, so I'm going to write an M there. Then N is at 0, 2. So I'm not going to go left or right any, but I am going to go up 2 spots. All right? So there's N. And then P is at 5, 2. So I'm going to go left 1, 2, 3, 4, 5, and then up 2 spots. Okay? Now notice, this is a triangle. So I'm going to go ahead and connect all those points and make up the triangle. There we go. Oh, come back. Now, we're going to translate this triangle MNP 5 units to the left and 3 units up. The easiest way to do this is to move the actual vertices, okay, the corners, and then draw in your lines again. So let's start with M. I'm going to go 5 units left and 3 units up. So here's M. I'm going to count 5 over. 1, 2, 3, 4, 5. And then we're going to go 3 up. 1, 2, 3. Now, I need to name this point. Now, notice this was M that's been moved. So I'm still going to call it M. The problem, though, if I just name it M, is that that's going to get confusing. Which M am I talking about? So what I'm going to do is, beside M, I'm going to write what looks like a little 1. Okay, we call that prime notation. Okay, and the way I would read this is M as part of our pre-image. Okay, this is what things looked like before we translated. This M prime is our new image after the translation. So this is my original point, and this is the new point after I've moved it, my 5 units left and 3 units up. So let's do the same for N. I'm going to go 1, 2, 3, 4, 5 units to the left, and then 1, 2, 3 units up. And we need to name this point too. We'll also call it N prime. Okay? Then we'll do the same thing for point P. So again, if I go 5 units left, 3 units up, okay, we end up right here at P prime. Go in real quick and we'll draw in our sides. And there it is. Okay? So let's draw out these actual points and write them out as coordinates. So I'll do it here. So M prime is now at the point -1, +1. So -1, +1. Okay? Let's look at N prime. Okay? N prime is now at, let's see here, it's at -5, +5. So -5, +5. Okay? And now let's look at P prime. Okay? It's at 0. Notice we didn't have to move left or right any to get to it. And we go up 5 spots. So at 0, 5. Now let's make an observation here. What do you notice about our original pre-image and our new image? Okay? One thing you should notice is that they're congruent. Okay? Again, translations are a rigid transformation, so these should look exactly the same. They do. Okay? Well, let's look at the individual points. What do you notice about all of the x-coordinates? Notice here we started at 4 and ended at -1. Here we started at 0 and ended at -5. Here we started at 5 and ended at 0. What happened to each of those points? Okay. Hopefully you recognize that they all went down by 5. Because again, they went down by 5 or subtract 5 because we're moving to the left. Anytime you go to the left, you're going to subtract. Anytime you go to the right, you're going to add. Okay? Let's look at the y's. -2 to +1. +2, +5. 2, +5. How did those change? Hopefully you realize that when we went up 3 units, our y coordinates, if you notice, also go up by 3. So if I'm going to go up, I'm going to add. Whereas, say, if I go down, I would subtract. Okay? We can write this in what we call coordinate notation. Here's what it looks like. Okay? We'll have our x and our y. This represents our pre-image. Okay? For example, point M has some xy coordinates. We don't know exactly what they are, in this case for -2, but this can be used for any coordinate. I'm going to draw an arrow. This arrow simply represents that I've got some sort of, pardon me, my phone's ringing. Sorry about that. Here we go. So our xy ordered pair, and then we've got our arrow to represent our transformation, in this case a translation. And then we're going to talk about what do our new points look like. All right? Well, let's look at our x's. Here we said that they were subtracted by 5. So I'm going to take my x's and I'm going to subtract by 5. Okay? Let's look at the y's. We had -2 to 1, 2 to 5. In those cases, we said it went up by 3. So I can write that as y plus 3. Here's the nice thing about coordinate notation. Instead of having to plot these points, graph them, and then sit here and count. In, for example, I had to count 1, 2, 3, 4, 5, and then up 1, 2, 3. I could use this coordinate notation and get to the same spot, say for n, a lot faster. Notice here, it says x. I'm going to take it and subtract 5. So 0 minus 5, what do you know, is -5. Well, let's try the y coordinate. Started at 2. If I add 3, what do you know? I'm at that +5. So using coordinate notation can get me to my new image without having to do all of this counting from each and every point. I can simply write out my new coordinates and then graph them. Okay? So this is a time saver. We'll be using these more and more, but for the time being, we'll still keep graphing. All right, let's look at another example in case this is a little much. So again, we've talked about things like prime notation, coordinate notation, pre-image, image, a lot of words being thrown around here. So let's try another example. Oop, did it again, didn't I? So let's do this new triangle. We've got triangle ABC, and it's located at -3. So let's see, we're going to go over 1, 2, 3, and then up 7. 1, 2, 3, 4, 5, 6, 7. Okay. So that's point A. We know B is at -1, 0, so that would be about here. And then let's see, C is at the point 5, 5. So 1, 2, 3, 4, 5, and then up 1, 2, 3, 4, and 5. So there's C. Let's connect the dots. We can do that real quick. When you do this on pencil and paper, though, a ruler might be nice, especially for some of those further distances. I'm cheating since I got a computer here. All right, well, let's talk about our translation. We're going to translate ABC 4 units to the right and then 5 units down. So if I do this graphically, I'm going to move each point individually. So let's start with A. 4 units to the right. Remember, we said if we're going to go right, that's adding. Okay? Or in this case, heading to the right. So let's do it 4 spots. So 1, 2, 3, 4 spots to the right, and then 5 units down. 1, 2, 3, 4, and 5 is right there. So that would be point A prime. So let's write that coordinate down. So A prime is located at 1, 2. So at 1, 2. Right. So let's try for B prime. Oop, not sure that didn't work out. B prime Right? B is here, so we're going to go 4 units to the right. So 1, 2, 3, 4 units to the right. Now 5 units down. 1, 2, 3, 4, and 5. And there's B prime. Okay? That's at the coordinate, let's see, -3. Excuse me, +3. And then let's see, we're going to go down. 1, 2, 3, 4, 5, so -5. Wonderful. C prime. So again, 4 units to the right. 1, 2, 3. Oh, ran out of space. Well, we'll say it's about here. 4. And then down 5 spots. 1, 2, 3, 4, and 5. So about here. And that's okay if you go off grid. Sometimes it happens. And there's C prime. So let's see. That's at the coordinate 1, 2, 3, 4, 5, 6, 7, 8. Goodness gracious, 9. And then we didn't go up or down any technically to get to it, so 0. Wonderful. All right, so let's connect the dots and make some observations. So there's A to B. Here's B to C. There we go. So again, some observations. Hopefully you realize once again that this is another rigid transformation. Okay? Meaning that our pre-image and our image are the same. They're congruent. Let's take a look at our coordinate notation. So again, we started off with points X and Y, whatever they happen to be. We did some sort of transformation. Let's talk about how the X's and Y's were altered. I went from -3 in A to +1 in A prime. -1 to +3. 5 to 9. Okay, if we look at our rules, we wrote it out in words, that was 4 units to the right. We said going to the right was the same as adding. So I added 4 every time. -3 plus 4 is 1. -1 plus 4 is 3. 5 plus 4 is 9. So I'm going to take all of my X coordinates and simply add 4 to them. Well, let's talk about the Y's. How did those change? Well, I went from 7 in A to 2 in A prime, 0 in B, to a -5 in B prime. And if we look at it in words, we went down 5 units. Down meaning subtraction. So if I took 5 here and subtracted 5 units, of course I'm at 0. So I'd write that out as Y and then -5. So again, with our coordinate notation, we'll look at our original point. So for example, -3, 7. And to get our new coordinate without having to do all this crazy counting, we'll simply take the X value, so -3 in this case, and add 4. Well, -3 plus 4 is 1. So I could have just written that down without having to do all this counting. If I wanted to get the Y coordinate, well, I simply take it and subtract 5. So 7 minus 5 is 2. So again, you can do these a lot faster if you use coordinate notation. Okay, if you're not comfortable with it, that's cool. Just simply count out the coordinates, label them out, and you're good to go. But you got to be able to use both methods eventually. All right. Well, this is where our translation portion will end. The next step that we'll look at will be our reflections. So the video is going to end at this point, and we'll pick up with a new video to start out with our reflections.